Imagine you are a lion. You haven't eaten in 4 days. The sun is burning. Your ribs are showing. Your body is screaming at you to eat something. Anything. And right there, just 50 meters away, is a leopard. Fully grown, full of meat. Completely alone. You are faster. You are bigger. You could probably take it, so why don't you? Most people think the answer is simple. Lions and leopards are rivals. There's some kind of animal code, some unspoken rule of the jungle. But that's not it. The real reason is something stranger. Something colder. Something that goes all the way down to the chemistry of flesh itself. And here's the thing. It doesn't just explain why lions ignore leopards. It explains how a single predator can change the course of a river. It explains why the food chain is one of the most fragile and terrifying systems on the planet. And it explains something about you, specifically. Because the same invisible logic that governs every predator on Earth has already shaped your life. You just didn't know it yet. Stay with me until the end. The last part is the one that will actually change how you see the world. Let's start with the most obvious reason. The one everyone assumes is the whole story, but isn't. Fighting another predator is a terrible idea. Think about it from the inside. You are a lion. Your entire survival depends on your body working. Your legs, your jaw, your eyes. One deep scratch across the eye from a leopard's claw, and you can no longer hunt. You can no longer eat. You are dead within weeks. Not from the scratch, from starvation. This is what ecologists call the injury calculus. Every predator carries it silently, in its instincts. The risk of attacking another hunter is not just high, it could be permanently disabling. A zebra might kick you, but a leopard will aim for your face and it knows exactly how to do it. In 2018, researchers at the Londolozi Game Reserve in South Africa documented this exact behavior across multiple lion prides. Lions would kill leopards, but almost never to eat them. It was a dominance move, a territorial statement. The actual flesh was left behind. Which is strange, because hunger was present, and food was right there. So why leave it? Here is where it gets really interesting. Predator meat is, in a very real biological sense, almost worthless as food. You have probably heard of the food chain. Energy flows from plants to herbivores to carnivores. But here is the part nobody explains. Every time energy moves up a level, 90% of it is lost, not reduced. Lost. A deer that ate 10 kilograms of grass only stored 1 kilogram of usable energy in its body. A lion that eats that deer only keeps 1 kilogram of usable energy from the deer. This is called the 10% energy rule, and it is one of the most unforgiving laws in all of biology. Now imagine a lion eating another lion instead of a deer. It would be eating a creature that has already burned off 90% of its original energy. The calories inside another predator are a fraction of what you would get from a herbivore of the same size. You would spend more energy fighting and killing it than you would ever get back by eating it. Nature is not sentimental. It is a math problem. And that math says, do not eat other predators. But here is the part that goes deeper than math. Predator flesh is poisoned. Not deliberately, accidentally, through a process called biomagnification. And it is one of the most quietly horrifying things in nature. Here is how it works. Heavy metals, industrial chemicals, toxins from the environment. These things do not dissolve in water. They dissolve in fat. They get stored in tissue, and they never leave. A blade of grass absorbs a tiny amount of mercury from the soil. A rabbit eats 1,000 blades of grass and stores all that mercury in its body. A fox eats 10 rabbits and stores all their mercury in its body. A wolf eats 10 foxes. It now carries the concentrated toxins of 10 foxes, who each carried the toxins of 10 rabbits, who each carried the toxins of 1,000 blades of grass. At every step up the food chain, the poison multiplies. By the time you reach an apex predator, the concentration of heavy metals, radioactive isotopes, and carcinogenic compounds in its flesh is staggering. Scientists studying Arctic ecosystems found that Inuit populations who ate polar bear and seal meat, which are top predators, had among the highest levels of environmental toxins ever measured in human tissue. The flesh of a top predator is, in a real chemical sense, a concentrated archive of every toxin it ever encountered throughout its life. If a lion ate a leopard, it would be ingesting decades of accumulated poison. Nature solved this problem the same way a smart investor solves risk. Diversify downward, eat lower, eat safer, eat the herbivores who are clean. And now we are getting to the part that connects all of this to something much larger, something that in 1995 changed a national park, and then changed a river, and then changed history. In the early 1900s, humans made a decision. They decided that predators were the enemy, wolves especially. In Yellowstone National Park in the United States, wolves were systematically hunted and killed. By the 1930s, every last wolf in the park was gone. And then something strange happened. The elk multiplied. With no wolves to fear, the elk stopped moving. They settled into the river valleys. They grazed without fear. They grazed constantly. They ate every young tree growing along the riverbanks. Without those trees, the roots that held the soil in place disappeared. The riverbanks began to erode. The rivers began to change shape. Wider, shallower, warmer. Fish populations crashed. Bird populations crashed. The entire ecosystem began to unravel, all because one predator had been removed. This is what scientists call a trophic cascade, a single change at the top of the food chain that tumbles downward, affecting every level below, all the way to the physical geography of the land. But then, in 1995, something remarkable happened. 14 gray wolves were reintroduced into Yellowstone. Within a few years, the elk began to change their behavior. Not just their numbers, their behavior. The wolves did not need to kill every elk. The fear of being killed was enough. Elk stopped standing still in the river valleys. They started moving. They started looking over their shoulders, and when the elk left the riverbanks, the willows grew back. The aspens grew back. The roots held the soil. The banks stabilized. Within 15 years, researchers documented that the rivers themselves had changed course. More narrow, deeper, cooler, cleaner. Doug Smith, the lead biologist in the Yellowstone Wolf Project, described it like kicking a pebble down a mountain where the conditions were just right for an avalanche. One species, 14 animals. And the rivers moved. When wolves were gone in the 1930s, there was a single beaver colony in the entire park. By 2010, there were 9. Wolves changed the rivers. And cleaner rivers meant that the drinking water flowing into nearby Billings, Montana, a city of over 100,000 people, became measurably cleaner. 14 wolves, a city's water supply. This is what predators actually do. They do not just kill. They regulate. They create the conditions in which everything else can survive. A predator eating another predator is not just bad math. It is ecological sabotage. Now here is where it turns back on you. Think about your own life, your own systems, your own hierarchies. You have your own food chains, your own trophic cascades. Every ecosystem you are part of, your job, your family, your community, depends on certain things staying in their place. Certain pressures existing, certain regulating forces doing their invisible work. When the top of a system is removed, the things that were kept in check expand without limit. The elk graze without fear. The banks erode, the rivers change. And the effects ripple down in ways that nobody predicted and almost nobody notices until it's too late. Think about what you have removed from your own life that used to regulate something else. Think about the pressures that seem annoying, the constraints that feel unnecessary, the forces you wish you could eliminate. Nature spent 4 billion years testing every possible configuration of predator and prey. It killed off every system that got the balance wrong. What survived is a razor-thin, exquisitely tuned web of mutual dependence. Predators do not eat other predators not because of some noble instinct, not because of an animal code, but because the mathematics of energy and the chemistry of poison and the architecture of entire ecosystems all conspire to make it the worst possible idea. And every creature that ever tried it differently is gone. The ones that survived learned to respect the chain. We are the only species that ever forgot that we are part of it, and most of us are still forgetting.